My topic for the science fair will be engineering, and the question for my topic will be how to create your own vacuum gauge. There are many types of instrument that measures pressure, and vacuum gauge is one of them. By definition, a vacuum gauge is a gauge for testing pressure after the production of vacuum. Usually, it measured as a negative value between 0 and 1 atm. So what I will need in order to make my personal vacuum gauge will be a jar that can also measure a vacuum gauge, or you can have a vacuum gauge separately inside the jar, and a pump to pump out a jar here. You will need a special jar to do it, and you also need your personal instrument over here. This will be measuring my vacuum pressure inside the jar. So, to make this instrument, you will first need to prepare a cap from a shampoo or something similar to it, a water, two clear straw, and scissors and glue gun. Disassemble the shampoo cap. Then stick a straw onto a shampoo cap. Hot glue it so that no air can be released between the straw and the shampoo cap. Stick another straw onto the other side of the shampoo cap. Hot glue it so that no air can be released between the shampoo cap and the straw. Cut off the straw so that it will not be too long or too short. Pour in some water only to one side of the straw. Hot glue the straw that you pour water on it, and make it sure that the water will not be released. So these two are the instruments that I created, and watch how there's air in this side of a straw. And the water starts at here for this side of the straw. And these are all labeled by millimeters, and we can see the water rising and measure it as a millimeter. So what I believe that will happen is as a surrounding environment decreases in pressure, the pressure in here, the air, will expand and push out the water, and then it's gonna rise in this straw. So I will be doing the experiment right now, and I'll be using this instrument that I made. I'll close the jar and start pumping out air. I'll be pumping out the air until 0.01 MPa. So from here on, I'll keep on pumping out air until it reaches other points, such as 0.02, 0.03, 0.04, 0.05, 0.06, and maybe 0.07. So instead of rising in a linear way, I figure out that the water rose more exponentially. To explain the logic behind this, I'll use description and picture. What I will be doing right now is explaining the phenomenon that's happening inside the instrument that I made. So let's assume that this is the instrument, the part where there is water inside, and it's the straw with the bottom on the bottom one. So there originally is a pressure here, and there's a ceiling here. The pressure cannot escape. There's water here. There's also pressure here. What happened is that the force of the water will go down, and the pressure will make the water go down even more. But then pressure outside will neutralize the water that's falling down. So the water is going to stay there. It's not going to accelerate. So if we were to look at this in equation form, the equation will be P2, which is the pressure over here, times the area, minus P1, which is the pressure over here, times the area, minus weight of the water, the mass of the water, mass of the water, which is here. These will equal to 0. And what I would do is convert W into rho AY times G. So how I did this is really simple. Rho is equal to mass divided by V, volume. And that will be converted into mass times mass is equal to rho times volume. And then the force of a gravity is equal to mass times gravity. This will be, so the m in this equation will be replaced by this one over here, and it'll be equal to rho times g times v. And what we also have here is v is equal to area times the height. So we will replace the v over here by area times width, area times height, and it's gonna be, and the w is gonna equal to rho times g times a times y. So after the conversion, we'll convert pressure P2 times A into nRT divided by V times A. So how we did this is really simple. Pressure times volume is equal to nRT, and then we divide V on both sides. It's going to be P is equal to nRT divided by V. And so it becomes like this, and then we will try to solve for Y this time. So divide A on both sides, and it's going to be this equation right over here. And we add rho y times g on both sides, and it's going to be this over here. Now, you divide rho times g on both sides, and it's going to be this. I'm sorry, this side is supposed to be g. So, from here on, what we're assuming is that Q is equal to nRT times PG. And we're assuming that K is equal to 1 over rho y. If that's the case, then we replace this value over here by Q and this value over here by K. Then it's going to be Y is equal to negative K times P1 plus Q over V. So this equation is very similar to Y is equal to mx plus B. The mx will be negative K times pressure, and then B will be Q divided by V. So the graph should look like this, something like this. However, we have two variables, variable V and variable pressure P over here. The volume will change every time, so this will not be linear, and the pressure will also change every time. They're not constant. The V isn't constant, so it's gonna change. So because of that, it should be this graph. It should look like this graph over here or this graph over here. To determine which graph I should be using, we need to look at the data we have. So in the first try, um, the in the first try, we can see that as the pressure decrease, so we're looking at from here, this point, assuming that this is where we started off, we're looking at pressure going down, so we need to look this way. So let's assume that this is the water rising. The water is slowly rising, and it's rising more quickly. This one, however, it's rising quickly in the beginning, but slowly later. So let's look at this. On this graph, we can know that the water is rising at later. And in the beginning, it's not rising much. So we should look at this graph over here. Hence, this instrument is exponential function. It's not linear. As clearly it shows on the graph, I did 3 tries and it all shows that the water rises exponentially.